Assalamualaikum and hello everyone. Welcome to our group presentation. Today we are going to discuss about radio wave propagation. Before we look at how they travel, what exactly are we talking about? Radio waves are a type of electromagnetic radiation with the longest wavelength on the spectrum. When we talk about propagation, we mean the movement and transmission of these waves from a transmitter like a cell tower to a receiver like To break this down thoroughly, our presentation will cover three main components. First, we will look at how radio waves travel through different mediums like air, vacuum, and water. Next, we will discuss the factors and behaviors that disrupt them, such as reflections. Finally, we will explore their real-world applications.
So next, I will talk about radio wave propagation in different mediums, which is vacuum, air, and water. First, let's look at radio wave propagation in a vacuum, also known as free space propagation. A vacuum is a medium that contains no matter, meaning there is no air molecules, particles, or obstacles. Unlike mechanical waves such as sound waves, radio waves are electromagnetic waves and do not require a medium to travel. In a vacuum, radio waves travel at the speed of light, approximately 3 times 10 power of 8 meters per second. Since there are no particles present, the waves experience almost no absorption, scattering, or attenuation caused by matter. However, the signal strength still decreases as the distance increases. This is known as free space path loss, where the wave energy spread out over a larger area as it travels. So, let's move on to radio wave propagation in air, which is the most common medium used in modern communication systems. Air allows radio waves to travel efficiently because it has relatively low absorption at many radio frequencies. Under normal conditions, radio waves travel through air at nearly the speed of light. However, the atmosphere is not uniform. It contains gases, water vapor, dust particles, and layers with different temperatures and pressures. These variations can affect the behavior of radio waves. One important phenomenon is refraction, where radio waves bend due to changes in air density. Weather conditions such as rain, fog, humidity, and storms can also influence signal propagation. Finally, we will examine radio wave propagation in water. Water is one of the most difficult mediums for radio wave transmission. This is because water, especially seawater, contains dissolved salt that makes it highly conductive. When radio waves enter water, much of their energy is absorbed by the medium and converted into heat. This causes significant attenuation, meaning the signal loses strength very quickly. Higher frequency radio waves are absorbed more strongly and can only travel short distance underwater. As a result, common communication signals such as cellular networks, Wi-Fi, and FM radio are ineffective underwater.
Okay, now let's explore the factors that affect the radio wave propagation. First up, we have frequency. Low frequency waves could travel long distance because they could bend around obstacles like mountains or buildings much easily. But in contrary, high frequency waves could carry a lot more information, but they tend to lose energy much faster. And next, we have atmospheric condition. Solar radiation constantly affects how signals bounce off the ionosphere during the day and night. Plus, the extreme everyday weather, like heavy rain, could scatter and weaken the signal strength. The third factor we have is obstacle. Obstacles like concrete structures and mountain terrains could reflect, scatter, or block radio signals, which force them to find a different path. And fourth, we have medium transition. When a wave hits the boundaries, like ground or sea surface, it will reflect, which can cause the signal to overlap and cause it to interfere. And lastly, we have distance. The farther a signal will have to travel, the more it spread out and dilutes, which will lose its strength quickly.
Now I will explain the behavior of radio waves during propagation. First is reflection. Reflection occurs when radio waves bounces off surfaces such as the ionosphere, buildings, or mountains. This allows radio signals to travel beyond the horizon and cover longer distances. Second is refraction. Refraction happens when radio waves pass through layers of the atmosphere with different densities. As a result, the wave bend and change direction, affecting the signal path.
Third is diffraction. Diffraction allows radio waves to bend around obstacles like hills, buildings, and other structures. This helps radio signals reach areas that are not in a direct line of sight with the transmitter. Lastly, scattering occurs when radio waves encounter particles, raindrops, or irregular surfaces. The waves are then dispersed in multiple directions, which can sometimes weaken the received signal. These behaviors play an important role in determining the coverage, strength, and reliability of radio communication systems.
Let's talk about the application. The first one is radio broadcasting. It's used to transmit news, music, and entertainment programs through AM and FM radio station. AM refers to amplitude modulation, while FM refers to frequency modulation. When radio waves reach the receiver, it detects the variation on either one of them and decoded the information therein. The next one is wireless internet, mostly used in Wi-Fi and Bluetooth technology that we use today. For example, like Wi-Fi, it transmits the information between devices and a route via frequency, depending on the data being sent. It can be from 2.4 GHz to 5 GHz. And the last one is navigation. For example, like GPS, the Global Positioning System. Radio waves help to calculate users' position on Earth. How? So GPS satellite sends the signals to a receiver on Earth. The receiver will receive from at least 4 satellites. Then the time taken is used to calculate the distance from each satellite. So that's how the user's location is determined. To conclude all, radio wave propagation allows wireless communication among users or even an object. By transmitting the signals through air, factors such as frequency might affect the signal strength to propagate to any medium such as water, air, and space. Thus, by understanding these principles, more application could be created in the future than what we already use daily, like GPS and wireless internet today.